Hello, Wizardos here. AOC 2024 Day 12 has landed, so let's solve it. If you have no idea about what infosec is, refer to the first link in the comments or description, or just watch my first video where I briefly explain it. Alright, time for the next day. Today's topic are web timing attacks. From what I've seen, these are race conditions, and that's a really interesting topic. If I can't steal their money, I'll steal their joy. So that sounds malicious. Werewolves Bank had a huge turnover this year and expected a massive profit before the holiday season. They were eager to disclose this news to the townspeople during the Sockmas celebrations. However, to their surprise, things went the other way around. After completing the annual calculations, the accountants were shocked to see a considerable loss. They observed discrepancies in the account balances. The bank called McSkate to help investigate these users' fraudulent transactions. Upon analyzing the bank's website transaction logs, McSkate found some interesting transactions. Two users, including the mayor's team, initiated multiple transactions from Werewolf's reserve accounts at once. Surprisingly, all these transactions succeeded despite exceeding the user's current balance. Glitch was already aware of the critical vulnerability allowing these fraudulent transactions. Mayor malware, his alliances exploited. They were gonna learn what are race condition vulnerabilities, what are the gaps introduced by HTTP2, how to exploit them, and how to fix them. That's always really cool to see not only how to exploit a vulnerability, but also how to fix it. That's pretty useful in bug bounty because when you write a detailed report, you always can write the POC, so like for example the script, how to reproduce the bug, what's the impact, and somewhere down there include mitigation. This will definitely increase your bounty. But yeah, let's start the machine and read. We need VM and attack box. VM is starting, attack box I have here. If you want to configure something like this, refer to my video on how to install Kali Linux and VMware somewhere in my channel. I have a tab here, so you can check it out later. But yeah, let's go. Conventional web applications are relatively easy to understand, identify, and exploit. If there is an issue in the code of the web application, we can force the application to perform an unintended action by sending specific inputs. These are easy to understand because there is usually a direct relationship between the input and the output. We get bad output when we send bad data, indicating a vulnerability. But what if we can find vulnerabilities using only good data? What if it isn't about data but how we send it? This is where web timing and race condition attacks come into play. Let's dive into this crazy world and often hidden attack surface. Yeah, I mean, from what I know, most people don't really know what race conditions is. Like most of the people at the lower levels. And yeah, this would be nice to learn about them. In simplest form, a web timing attack means we glean information from a web application by reviewing how long it takes to process our request. By making tiny changes in what we send or how we send it and observing the response time, we can access information we are not authorized to have. Race conditions are a subset of web timing attacks that are even more special. With a race condition attack, we are no longer simply looking to gain access to information, but can cause the application to perform unintended actions on our behalf. Web timing vulnerabilities can be incredibly subtle. Based on the following research, response time differs ranging from 1300 milliseconds to 5 nanoseconds. Have been used to stage attacks. Because of their subtle nature, they can also be hard to attack and often require a wide range of testing techniques. However, with the increase in adoption of HTTP2, have become a bit easier to find and exploit. Yes, this is the research from Portswigger, very cool source, you can check it out. I'll probably also add the comments link to Portswigger's Academy on race conditions, so you can broaden your knowledge and horizons. And yeah, overall the attacks start to get much more interesting. There's also TryHackMe group on HTTP request smuggling, which is another amazing topic. You can check it out after race conditions. And yeah, I had something to say, but I forgot about it, so let's go. HTTP2 was created as a major update for HTTP, the protocol used for applications. While most applications still use HTTP 1.1, there has been a steady increase in the adoption of HTTP 2, as it's faster, better web performance, and has several features that elevate the limitations of HTTP1. However, if implemented incorrectly, some of these new features can be exploited by threat actors using new techniques. A key difference web typing between HTTP1 and HTTP1/2 is that 2 supports a feature called single packet requests. Network latency, the amount of time it takes for a network to reach this web server, made it difficult to identify web timing issues. It was hard to know whether the time difference was due to web timing vulnerability or simply a network latency difference. However, with a single packet multi-requests, we can stack multiple requests in the same TCP packet, eliminating network latency from the equation, meaning time differences can be attributed to different processing times for the requests. This is explained more in the information below. Alright, so let's maybe start with the beginning. With this thing passed, the only server latency remains, making it significantly easier. So it goes the request, and we have the response, which is 30 milliseconds. We send the request, the response 33 milliseconds, that's another one. And now we send both at the same time in one TCP packet. We get the response in also one TCP packet. So yeah, it's actually how it works. With network latency a thing of the past, the only server latency remains, making it significantly easier to detect timing issues and exploit them to recover sensitive information. Yeah, about the race conditions, one of the Linux kernel previous exploits, Polkit if I recall correctly, utilizes race conditions. So yeah, we don't see it only in web. Timing attacks can be often divided into 2 main categories: information disclosure, leveraging different in response delays. A threat actor can uncover information they should not have access to. For example, timing differences can be used to enumerate the usernames of an application, making it easier to stage a password guessing attack and gain access to accounts. Then we have race conditions, which are similar to business logic flaws, in that a threat actor can cause the application to perform unintended actions. However, the issue's root cause is how the web application processes requests, making it possible to cause race conditions. For example, if we send the same coupon request several times simultaneously, it might be possible to apply it more than once. For the rest of this task, we'll focus on race conditions. We'll take a look at time check of time of use. So let's use an example to explain it, as shown in the animation below. We time apply discount, use then set the 7-second code. Send 2 requests at the same time, you get 2 responses, which then applies discount and sets code already used. Right. When user submits their coupon code in the actual code of the application, at some point we perform a check that the coupon is valid and hasn't been used before. We apply the discount and only then we do update the coupon code, indicate that it has already been used. Example: between our check if the coupon is valid and our update of the coupon being used, there are a couple of milliseconds where we apply the coupon. While this might seem small, if a threat actor can send 2 requests so close together in time, it might happen that before the coupon is updated, request 1 has already been checked in the request 2, meaning that both data requests will apply the coupon. By the way, from more the programmatic side, if we have something like this and we, instead of setting coupon to already used, we delete the record from database. Now it will not interfere with the IDs, because when you generate ID and you delete some part, the ID doesn't change. Bingo. Winning the race. Now that you understand basic concepts related to race conditions, let's explore how this vulnerability occurs in a real-life world scenario. For this, we'll take an example of the WhereView banking application hosted on this IP address. The application allows users to log in and transfer funds between accounts. We need to launch burp suite. Yep, this will be recently used burp. This is going to load for a while. Before we start receiving requests, we need to configure the environment so that, as a pen tester, all the web traffic from our browser is routed through burp suite. This allows us to see and manipulate requests as we browse. We'll use burp, a powerful web scanner, to intercept and modify requests. You can access burp attack box, this icon. Then we can just choose temporary partition memory, because only Professional allows us to do something like save a project. Once the burp has started, you will see its main interface with 3 different tabs: proxy, intruder, and repeater, and others. And probably they focus on proxy, intruder, and repeater. So like basically proxy, when you intercept the request, you see all the packets, all the requests with their information. Intruder is where you can create attacks such as brute forcing or just enumerate. Pretty much send data to the same place over and over again from a word list. Something like you would do with Hydra, for example. Also, there's a cool room on burp from TryHackMe, but I don't think it requires you to have premium account. So never mind. And the repeater, you can see directly all the requests and responses we send them. You're gonna see it probably. Inside burp, check settings. You'll see tools. Enable allow burp's browser to run without a sandbox option. Click close icon. Alright, so let's go to settings, because I don't think dashboard. Settings here. Then we'll go to burp's browser. Yes, because burp's it has built-in browser. Allow burp's browser to run through the sandbox. Scanning hostile website without the sandbox increases the risk of your local system being compromised. We're not scanning hostile website right now, so yeah. After allowing the browser to run without the sandbox, we would now be able to start the browser with pre-configured burp's proxy. Open the browser by clicking Open Browser, key proxy, intercept and browse to the URL. This is so that all requests are intercepted. So yeah, so we go here, we go to proxy. Maybe let's right now save this. I guess it's saved itself. We click on Open Browser. In the first room from the burp zip module, you have how to configure Foxy Proxy to run with burp. But I'm gonna follow along this room. So let's visit the site. And you see I forgot something, because right now we have to also click this intercept on. If we refresh, you see we got the request. We can see what it looks like. Well, it looks like raw, and even the hex if you need it. And yeah, we don't need to analyze or do anything with it. We can just click forward, and it's here. Cool. Once you browse the URL, all the URL requests are intercepted and can be seen under the proxy HTTP history tab. Yes, we can just go to here, HTTP history tab, and yeah, to request slash and some file icons. Right. As a penetration tester, one key step in identifying race connection is to validate functions involving multiple transactions or operations that interact with shared resources, such as transferring funds between the accounts, reading and writing the database, updating balances consistently, etc. For this example, we will log into the Whereville banking application using credentials 110 and password tester. Alright. Account is 110, password tester. And you see, that's why you don't see passwords in HTTP, because if I enter the request, I can just see it. Let's send it forward. We have the response, we have the session key. It's probably some sort of, yeah, I mean, I'd say this runs some Flask for the application, because this looks like a JVT. That's basic error. Forward, yes. You will see two functionalities: logout, which probably does not involve simultaneous accounts, and next is fund transfer, which includes deducting funds from one account and then to the other account. As a pen tester, this could be an opportunity for an attack. We will see in detail how, as a pen tester, you can test/exploit the vulnerability. We'll browse the bank application and perform sample transactions inside the browser. Create multiple get and post requests, and whenever the request we pass through burp suite are clear. The burp suite, yeah. As shown, our current balance is $1,000, and we're gonna send $55 to our bank account with the number 111. While doing that, all requests will be captured in burp. Our burp is capturing, it's good, so let's send 111 and send 500. Alright, it's here. Click on the transfer button and you see the following message indicating that the amount has been transferred. Now let's review fund transfer port, load the proxy tab. By the way, I've never knew what HTTP history is for, so right now have it. And yeah, do I have here response as well? Yes, I do have here response as well, so just forward it and go to HTTP history. Have response, have the request. Yeah, forward. Alright, it's good, it's good. We can see the above figure shows the transfer endpoint accepts post request parameters, account number, and amount. Burp Steve has a feature known as a repeater that allows you to send multiple requests. We use this feature, so we go back, we go to Burp, and choosing this, we click Ctrl R, or just right click and send the repeater. We use this feature to duplicate our post request and send multiple times to exploit the race condition vulnerability. Right click on post and send the repeater. Now navigate to the repeater tab where you find the post requests that needs to be triggered multiple times. We change the account number from 101 and the account from 5000 to 500 to any value in the request as well as shown below. Change for that. We can change, yeah, we can change what we want to change, so let's stick with this here. Place the mouse cursor inside the requests inside the burp, place Ctrl R to duplicate tab, plus 10 times have 10 duplicate requests ready for testing. Alright, so we're gonna need to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, 10. Now we have 10 requests ready, we want to send them simultaneously. By one option is manually to click send button each time. Tab individually, we aim to send them all in parallel. To do this, click the plus icon next to request 10 and select create tab group. This allows us to group all the requests together for easier management and execution in parallel. Alright. Create tab group, that's a be yeah. Then we, after clicking create tab group, a dialog box will appear asking you to name the group and select the request to include. For this example, we will give the group found and click create option below. Alright, so we first we need absolutely every single one. Let's go, and let's say maybe 9. Gonna be different, and maybe we give it a nice color. Create. Alright. Now we are ready to launch multiple copies of our HTTP post requests simultaneously to exploit the race condition vulnerability. Select send group in parallel, last byte sync, and drop down send button. Once you've selected send button, we'll change to send group and click the button to send all duplicated requests in our tab group at the same time as shown below. Send group parallel. Last. Once all the requests have been sent, navigate tester account in the browser and check the current balance. You will notice that the tester's balance is negative because we successfully transferred more funds than were available in the account, exploiting the race condition vulnerability. Alright, let's go. Last byte sync, yes, and send group. Alright, we got back. Let's maybe... yeah, we go to proxy, I forgot, and forward. It's there. You see, we are minus 3,500. By duplicating 10 requests and sending them in parallel, we are instructing the system to make 10 simultaneous requests, each deducting 500 from the tester's account and sending it to account 111. In a correctly implemented system, the application should have processed the first request, locked the database, and processed the remaining requests individually. However, due to the race condition, the application handles the requests abruptly, resulting in negative balance in the tester account and an inflated balance in account 111. Now verifying through source code. Suppose you're a penetration tester with access to the application source code, as in a white box pen testing scenario. In that case, you can identify potential race condition vulnerabilities through a code review. By analyzing the code, you can pinpoint areas where multiple database operations are performed without proper transaction handling. Below is the Python code that handles the fund transfer. Alright, so here we see if user balance greater or equal to the account amount, set balance where account number, commit, execute. In the above code, if user balance is greater or equal to the amount, the application first updates the receipt to the balance with the command, followed by a comment, then updates the sender balance using update user set balance equals balance minus something where amount where account number equals this, and commits again. Since these updates are committed separately and not part of a single atomic transaction, there is no locking or proper synchronization between these operations. This lack of transaction or locking mechanism makes the code vulnerable to race conditions. Alright, so single atomic transaction and race conditions. Time for some action. Now that you understand the vulnerability, can you assist glitch in validating it using the account number 101 and password glitch? Then to explain the vulnerability by transferring over 200,000 from his accounts to the account number 101. Fixing the race. The developer did not properly handle concurrent requests in the bank application, leading to a race condition vulnerability during fund transfers when multiple requests were sent. In parallel, each conducting and transferring funds, the application processed them simultaneously without ensuring proper synchronization. This resulted in inconsistent account balances such as negative balance in the sender's account and excess funds in the recipient's account. Here are some of the preventive measures to fix the race. 1. We can use atomic transactions. Developers should have implemented atomic transactions to ensure that all steps of a fund transfer are performed as a single unit. This would ensure that either all steps of the transaction succeed or none do, preventing partial updates that could lead to an inconsistent state. Then also implement mutex locks could have ensured that only one thread accesses the shared resource at a time. This would prevent multiple requests from interfering with each other during concurrent transactions. Then also apply rate limits. Developers should have implemented rate limiting on critical functions like fund transfers and withdrawals. This would limit the number of requests processed within a specific time frame, reducing the risk of abuse through rapid repeated requests. After completing the exercise, you'll be required to visit dashboard to get the flag. Alright, so we need to log out of our this. You can also go to repeater and like can I just edit group and maybe just dismantle it or something? Close it off, yes. Now we have tab number 11 because it's like this. And yeah, we're gonna look in with 101 and glitch as a password. Forward, yes, and the response is back. We're here. Right, so now we need to. What do we need to do? We need to transfer. Yes, nice. We need to transfer over from glitch account to account number 111. Alright, so we need to go here. Then we're gonna input to 111 500 and we're gonna capture it. We're gonna send the repeater, and that was like 1 2 3 4 5 6 7 8 9 10. Now we're gonna create a tab group where we're gonna have 1 2 3 4 5 6 7 8 9 and 10. This request will be purple now. Create. And now we're going to simultaneously send group in parallel. Let's go. Let's maybe refresh this page now. Yep, we can send this forward and forward. And yeah, we have balance of minus 3,000. Let's refresh the page. And yeah, here's the flag. We won the race. That's so cool. Yeah, let's click this as well and click this as well. And we're done. that was actually a pretty cool intro into race conditions. Like, I mean, here everything was clearly explained. Actually, it's not that tricky as I thought so. So yeah, another challenge is done, and another time, TryHackMe surprises us with how simply they can explain terms. And yeah, thank you so much for watching. I hope you enjoyed it. If you liked it, leave a like, subscribe, comment something positive, join us in waiting for Christmas. And yeah, that's about it. See ya.